Hi everyone, welcome to this episode of Keipert Labs. In this video we're going to be introducing the valence model of bonding. And we're going to start by quickly just kind of recapping some of the key ideas we've been learning about so far. So we've seen that in the past that we have been interested to know whether an atom will form ions or form molecules when it comes to form a compound. In the previous video, we looked at the idea that first ionization energy is a powerful predictor of whether an atom will form an ion or will need to form molecules. And that if it's going to form an ion, whether it's going to form a positive or a negative one, and what charge it will have. And so what we were able to do was use the first ionization energy to introduce these three categories of atoms based on their attraction for electrons. So strong, intermediate, or weak attraction for electrons. Okay, and so we introduced this kind of spectrum and said that, all right, if an atom had a first ionization energy less than 7.8, it had a weak attraction and tended to form positive ions. And in order to form those positive ions, it gave up all of its valence electrons to do so. We said that if it had a first ionization energy of greater than 10, it's strong and it tends to form negatively charged ions, and it will gain as many electrons as it needs to fill up its valence shell. But then we identified that in between that we had this intermediate category between 7.8 and 10 where it didn't form ions at all, that rather that then it tends to form molecules. But so now we need to develop our atomic model to be able to explain how atoms can form molecules at all. How is this bonding happening, and how can we explain how it works? And so what we're going to do is that we're going to regress to childhood just a little bit, and we're going to use Lego. Okay, so what we're going to do is we're going to actually make models of compounds that are molecules using little Lego bricks. And we're going to talk you through that a little bit and lay out a couple of ground rules, and then give you an example or two, and then the rest is over to you. Okay. In the hydrides activity that you've recently done, we were then looking at, all right, what's the ratio of different things in some common compounds to do with hydrogen, that is, hydride compounds. And so that we saw a couple of ratios, saying that for every one carbon, we have 4 hydrogens. Okay, we have CH4. For every one nitrogen, we have 3 hydrogens, NH3. For every one oxygen, we have 2 hydrogens, H2O. And for every one fluorine, we have 1 hydrogen, HF. Okay? Now, in principle, it would probably, you could see that we've written hydrogens second and here and first here. That's kind of just from convention. It's not really from anything like particularly concrete. Yeah, it's just there are some common ones to kind of work with here. So what we can then see is, all right, well, hydrogen is obviously able to make connections with different atoms, but in different ratios. And that for every, so that carbon is obviously able to connect to 4 different things. Nitrogen can connect to 3 different things. Oxygen can connect to 2 different things, but fluorine can only connect to 1 thing. And that hydrogen can only make 1 connection to a fluorine. Each hydrogen makes 1 connection to an oxygen, a nitrogen, or a carbon, which is partly why we get these numbers. And so what we're going to do is we're going to use some Lego bricks to model carbon, nitrogen, oxygen, fluorine, and hydrogen, and practice doing this. And then we can start to develop a model to explain some more complex compounds. Okay, but so firstly, what we need to do is develop 3 key ground rules to have success with this activity. Now I'm just going to write these up for you now. So the first rule is only make. So we're going to be connecting Lego bricks together, and so you're going to be only making 2 rows in the models that you make. So here we've got top and bottom rows. Okay, so we're not going to be just making a really big tower or a really big stack, that we're only building things kind of across in those 2 layers. The next thing is that each pair of studs, which is the technical name for the little bumps on top of a Lego brick, equals 1 connection. Okay, so this Lego brick here can only make 1 connection to something else, even though that's those 2 studs. And then the final rule is that all studs must be filled or used. There's no spares and no empties. Okay, so that you couldn't make a connection like that, and just say that's my compound. Okay, because you've got 2 empty starred pairs over here and then 2 empty ones over here. Okay, so you've got to make sure that all the gaps are filled. All right, so thinking about our modelling over here, so what we're going to do, we saw that hydrogen can only make one connection. So we're going to represent a hydrogen with a 2x1 brick. Okay, we saw that fluorine can also only make one connection. So when we are using fluorine, we need to use the same type of brick. Okay, now colour here is totally not important. I've just raided my kid's basket, so just, make of that what you will. Oxygen can make 2 connections, so we're going to use one of these bricks. Nitrogen can make 3 connections, so we're going to make one of those bricks. And then carbon can make 4 connections, so we're going to use a 2x4 brick. Okay, so now we're going to actually, I'll keep this here for now and see if I can work with it. And let's make a model of CH4 as our first example. So I'm going to try and do it side on so you can see this as clearly as possible. So I've got 1 carbon and I've got 4 hydrogens. So 4 lots of this same type of brick. And I'm going to connect them up. Okay, so I'm connecting all these hydrogens onto my carbon like so. Now, it doesn't matter for this activity whether you connect them on the top or you connect them underneath. Okay, all we're really looking for here is a model of the ratio. And what you would do, having done this, then you would draw a diagram. Okay, so I would do it like this, and I'd do like that. And there's your CH4. So your carbon and 4 hydrogens. Okay, that's as simple as your model needs, your diagram needs to be. Okay, and so then you can start going through the other hydrogen kind of compounds and make those models there. And so then you get to the next kind of part, and just to give you a bit of a prompter, and then the rest will be up to you. So then you're saying, all right, asked to make compounds involving 2 carbons and as many hydrogens as will fit. Okay, so you've got 2 carbon bricks that need to connect to each other. Okay, they can't just be next to each other because they're not connected together. They have to be connected somehow. Now, they could be connected like this, and then filling in hydrogens top and bottom over here. But, just a little tip, you could make more than one connection to your carbons, and then see what happens. Okay, the rest is over to you. Good luck. Thanks very much for watching. Bye for now.